So far, we've analyzed data graphically. We've drawn pictures to show how variables are distributed. But we had said very early on when we were describing what the course was going to be about that we would also do numerical summaries of data, more drastic summaries, summarizing an entire variable by one or two numbers. And that's what we're going to start on now. We're going to start with percentiles, and perhaps you might have seen a percentile or two in your life elsewhere. Certainly in the United States, when babies are born, the doctors measure all kinds of characteristics of these little creatures and present the parents with percentile ranks on heights, weights, and so on. And you might have seen percentile ranks on exams. So if you're on the 95th percentile of scores, I hope you feel rather happy. Why do you feel happy? Because you feel you've done well. So what exactly is the 95th percentile of scores? Well, for one thing, it's a score. And it's a good score because 95% of the students didn't do quite as well. And some people say it even with some redundancy in the form 95% of the students did worse and 5% did better. Now I've put those in quotes for a reason, because you have to be a little bit careful. There are the people who scored exactly that much and they fall neither in the lower group nor in the higher group, so where are they? There are all kinds of little questions that arise. Those aren't terribly important for what we're about to do, but still I'm going to have them in quotes. It's still fine to use this informal notion of what a percentile is for now. And by the way, we should meet some famous ones. There are three in particular. The 25th percentile is the lower quartile, that's from quarter. The 50th percentile is called the median. It's the halfway point of the data. And the 75th percentile is the upper quartile, lower and upper coming from the idea that these are points on the horizontal axis of a histogram. And in terms of the histogram of scores, what is the 95th percentile of the scores? It is a score, and the total area to the left of this score is 95%. And what we're going to do now is take a look at a histogram and see how we can read percentiles of that histogram. And we'll go back to our old friend, the income distribution. And whose incomes were these? These were the incomes of adults in the United States. Went from about nothing to $150,000. We talked a little bit about this table. In fact, we talked quite extensively about this table. And what we're going to do now is we're going to start adding up the areas from the left. So from 0 on up. So from 0 to 10, there are 20% of the people, and so we leave that. 0 to 25, it's 20 plus 28, and that's your 48. 0 to 50, 20, 28, and 27, and that's your 75. And these sums on this rightmost column are called cumulative sums because they are accumulating. Each one is bigger than the other. Each one is the other plus an additional amount. And you can see from this table that the percent of people who had incomes in the $0 to $50,000 range was 75%. In other words, the 75th percentile of these incomes was $50,000. And that's a lot easier to see in a picture. If I look at the area to the left of 50,000, there's your 50,000, and you're looking to the left, then that's your 20%, that's 28% here and 27%, and the yellow bars add up to 75%. And therefore, 75% of the incomes were below $50,000, which means that $50,000 is the 75th percentile of the incomes. Straightforward enough, and very convenient that these three bars add up to such a nice number, 75%. Had somebody asked me for the 80th percentile, I'd have had a little more trouble providing it because it's not at the edge of a bar. The median, the 50th percentile, is not at the edge of a bar. 20 and 28 would give me 48 here, and then I'd need to get a little bit more out of this one. And so before we get into doing things like that, what I'd like to do is examine the assumption behind this statement here, that the 75th percentile is $50,000, and it's that old assumption that we've been making, which is coming from the flat-topped bars. And what's that assumption? Yep, it's the assumption that the people are uniformly distributed in this interval, and in this interval, and in this interval. And as we said before, that assumption may or may not be good, but under that assumption, this estimate makes sense. If that assumption weren't true, then, for example, you might have these 27% of people not uniformly spread over here, but all bunched up at the beginning of the interval, and then nothing here. Well, in that case, the 75th percentile wouldn't be here at 50,000, it would be somewhat less. But under the assumption of uniformity, it is here. In fact, under the assumption of uniformity, you are essentially assuming that the variable is continuous. And so you don't have to worry about gaps and bunching and so on. So how do we find percentiles that are not at the edges of the bars? Well, in fact, it turns out that assuming uniform distribution, we can, in fact, estimate any percentile, whether it's at the edge of the bar or whether it's not. And you, in Stat 2.1x, have two ways of doing this. One way is by calculation, which I'll show you in a bit, and another way is by appealing to technology that is available to you in this course, namely your online textbook. And that is where we are going to go now. So, here's chapter 3 of your online text, and this is figure 3.2, and it is, you guessed it, a histogram. What is it a histogram of? Well, let's see. Histogram of deviations of g. That sounds terribly hard, but really it isn't. G is acceleration due to gravity. It's what makes you fall down. And that is roughly 9.8 meters per second squared. And in this particular experiment, the reference number was 9.79 something or other meters per second square. The details are in the text. And that reference number was called 0. And then what the scientists did was they measured the gravitational force over and over again and computed that acceleration, and what was recorded was how far off each of their measurements was from this reference number. So this 50 means that measurement was 50 units higher than the reference number, and this minus 100 means this measurement was 100 units lower than the reference number. The units also are defined carefully in the text. Now, if you take a look at the histogram, it's clear that the majority of the measurements were below the reference number. So what is this area line doing for you? Let's take a look at what the text does. The area from minus 160, where's minus 160? Minus 160 is the low end here, all the way to minus 160, which is still here, and that is why that area is 0. There is no area between minus 160 and itself. However, if you start to change this right end, look what happens. You see the yellow area that is shaded is 12.24%. So for example, if I wanted the 10th percentile, then I would come down a bit. And I can never do this properly. without actually typing. Okay, that's 9.1. So why don't we try minus 108? And that area from minus 160 to minus 108 is 10%. No, I didn't just guess that. I've seen these data before. And so what the software is doing for you is it is simply telling you that the 10th percentile of these data was minus 108. Very easy, just click and drag. Where's the median? Well, for the median, we just keep going until we hit 50, do we not? And I'm never going to be able to stop at the right place. I hope you're better at this than I am. 43, 45, almost there. Right, very, very close. I didn't do so badly. I think it's minus 43, if I remember correctly, and I do. The median is negative 43. Again, the area from the left all the way up to negative 43 is 50%. And so, if you have your online textbook and your data entered into its system, which later on we will teach you how to do, then you can simply click and drag and you will find percentiles. But you know, you won't always have your online textbook. And so you probably want some other tools with which to be able to do it. If you haven't entered your data in here, you can't use the system anyway. So let's figure out another way to do it. So what we're going to do is we're going to return to our old friend, the income distribution, and try to find its median. And I'll remind you that the median is not quite at the edge of one of the bars. The first bar was 20%, the second bar was 28% in areas. The total is 48%. For the median, you need another 2%, and that's going to be in this next bar from $25,000 to $50,000. So you have 48%, the yellow area is 48%, you need another 2%. How much do you think you have in here? Do you remember from the table? Even if you don't, surely you're going to agree with me that it's bigger than 2%. Surely. If that's 28%, then this is certainly bigger than 2%. So you want to go into this bar, but you know you're not going to go all the way in. You're going to go part of the way into this bar. Its area is 27%, and so your median that you're going to try and find is somewhere in this range, and your job is to find where it is. In other words, your job is to say, I'm going to start at 0 and I'm going to keep going, and I'm going to keep going, and I'm going to keep going until the area to the left of my point is 50%. And that's the point I need to find. So how do we do that? Well, these yellow bars have a total area of 48%, and we need another 2%, as we've said a couple of times. So we are going to start at the left end of our interval, that is 25. We are going to start at 25, and then we're going to walk a fraction of the width of the bar. Now, what fraction are we going to walk? Well, we want another 2% of area, and what's in the entire bar is 27%. And so the fraction that we're going to walk is what we want, which is 2, over what we've got, which is 27. And we're going to walk this fraction, 2 and 27, of the width of the bar. The bar starts at 25, ends at 50, so its width is 50 minus 25. So once again, start at the left end of your bar and walk the appropriate fraction of the width of the bar. And if you do that calculation on your calculator, you'll get $26.85 thousand roughly. And so that's a point that's just about somewhere here. And there's your estimate of the median of the distribution, based, of course, on the assumption that you have uniform distributions within each bar because we've been assuming that going a certain fraction into this interval gives you that fraction of the area. And just for one more example of this calculation, let's find, or at least estimate, the 80th percentile. Same table. Now we're good enough at this that we don't need to be looking at the picture. We start adding up areas from the low end. So 20%, and then you add to that 28%, you've got 48. You add to that another 27, you've got 75. You're heading for 80. You're heading for 80. If you go all the way to 100, you've overshot it. So you know that your 80th percentile is going to be in the 50 to 100 interval. So what do we know about the numbers in the interval? Well, we know, as we said, that we need another 5% of the area, and the interval contains 18% of the people, so the bar has 18% of the area, and we want 5% of it. And so what is our calculation? We start at the left end of the bar, and then we walk a certain fraction of the width of the bar. What is the fraction? It's the percent that we want relative to the percent that we have in the bar. And if you work that calculation out, you have roughly $64,000, just under that. Always assuming, of course, that you have uniform distribution within the bars. If you do not have that, then all bets are off. These estimates don't work.